1.8 experiment aim to study the effectiveness of various oils in forming emulsion. Theory: emulsions are those colloidal solutions in which both the dispersed medium in large quantity and the dispersion phase in small proportion are immiscible liquids. They are of two types: oil in water emulsions. In this type of emulsion, oil is added in small amount in water and hence oil acts as dispersed phase. Water is present in excess, therefore water acts as dispersion medium. Water in oil emulsions. In this type of emulsion, water is added in small amount in oil and hence water acts as a dispersed phase. Oil is present in excess, therefore oil acts as dispersion medium. Mixing capacities of different oils with water are different. Thus, liquids separate out on standing. A substance known as emulsifier or emulsifying agent is added to stabilize the emulsion. Soap is a good example of emulsifier, since one end of its molecule in lipophilic, oil-loving and other hydrophilic, water-loving. Requirements: apparatus, measure cylinder, stopwatch, glass tube and pipette. Chemicals: olive oil, distilled water, soap solution, cottonseed oil, coconut oil, castor oil, mustard oil, lanolin. Procedure: take 5 test tubes, mark them as A, B, C, D and E. Put 10 ml distilled water and 10 ml of different oils in each test tube. Then add 5 drops of 1% soap solution in test tube A. Shake it well and allow it to stand. At the same time, start the stopwatch and note the timing of separation of the layers. Perform the same experiment with test tubes B, C, D and E. Repeat the whole experiment with the same procedure with dilute solutions of shampoo and lanolin. Observations: greater the time taken for separation into 2 layers, more stable is an emulsion and more effective the oil is in forming the emulsion. Result: the effectiveness of different oils in forming emulsion is in the following increasing or decreasing order. Shake the test tubes vigorously, but take care that the liquid does not come out. Shaking should be done in each case for the same duration and use same method of shaking. Example: vigorous shaking or swirling. Volume of the liquids should be measured accurately. Time of separation of 2 phases should be recorded accurately. Start the stopwatch immediately after shaking.